from the Stone Age to the Bronze Age, and from the Bronze Age to the Iron Age. The importance of materials has been recognized throughout history. One important attribute of materials is their strength characteristics, and through time, there have been many different tools for measuring the strength of materials. The oldest is the common hardness test, dating back to 1722. Hardness testing involves pushing a hard indenter into a sample with a known force and measuring the size of the residual indent. Different types of hardness test differ only in the shape and size of the indenter. For a given indenter and force, the indent size depends on the resistance of the sample to plastic deformation. A hardness number is defined as the force divided by the area of contact between indenter and specimen. At around 1890, late in the 19th century, early tensile test machines started to become available. The tensile test has remained since then the gold standard in mechanical testing, and it continues to be the go-to method for measuring stress-strain curves. During the test, a test coupon with a well-defined geometry is gripped at both ends before it is stretched under the application of a measured axial force. The degree to which the test coupon elongates is also continuously monitored, and when the test finishes, the measured forces and displacements can be converted to stresses and strains, such that the stress-strain curve can be obtained and analyzed. However, tensile testing also suffers from some limitations, including high capital investment costs, coupon preparation difficulties, and clamping and slippage challenges. Also emerging at about the same time, 1901, was the Charpy impact test for measuring the fracture energy of materials. The test technique is popular because of its simplicity and the ease with which specimens can be prepared, and it continues to be used extensively. The test consists of striking a suitable specimen with a hammer on a pendulum arm, while the specimen is held securely at each end. The hammer strikes the face that is opposite the face with the notch. The energy absorbed by the specimen is determined precisely by measuring the decrease in kinetic energy of the pendulum arm. But like time itself, technologies move on and new capabilities emerge. Indentation plastometry is a new method for measuring stress-strain curves and metal strength parameters. But it is simpler and quicker than conventional tensile testing, and you can test real components. Indentation plastometry involves the creation of an indent, followed by measurement of the full profile shape. This shape is then analyzed using finite element analyses and optimization algorithms in order to determine what the underlying strength characteristics of the material are. It can measure stress-strain curves in under 3 minutes. So, don't get left behind. Whatever your materials testing requirements are, it's probably best to make sure that you're no longer consigned to working in the Stone Age.